Hey there, this is the homework tutorial for the honors first day of ionic bonding. I'm going to do some of the highlighted problems for you today. So we'll start here with nitrogen. So how many valence electrons does nitrogen have? Well, pull up your periodic table. Nitrogen is in group 5A, which means it will have 5 valence electrons. Is it a metal or is it a non-metal? Well, you got to kind of look at this zigzag line here. Everything to the right of the zigzag line is a non-metal, to the left is a metal, so that makes nitrogen a non-metal. So we'll put NM for non-metal. Will it gain or lose electrons? Nitrogen has 5 valence electrons. It wants to have 8 valence electrons for a full valence shell. So it will need to gain 3 electrons in order for it to have those 8 valence electrons. So it will gain electrons and it will gain 3 of them. So it's going to gain, and it will gain 3. So we'll go ahead and put how many it gains. So what's its oxidation number? Well, without a rule or anything else, we'll say nitrogen. Since it gains 3 electrons and electrons are negative, we say that its oxidation number is -3. Okay, that means it gained 3 negative charges to have 8 total negative charges in its valence shell. So it will gain 3 electrons. That's what that minus means. Is it a cation or an anion? Well, negative ions are called anions. Okay, electron dot. We're going to do electron dot and then the formula for this problem for beryllium and nitrogen. So beryllium symbol is Be. I need to find out how many valence electrons it has so that I can do its electron dot properly. Beryllium is in group 2, so it will have 2 valence electrons. 1, 2. And then we also have nitrogen, so we'll put nitrogen right here. And nitrogen has how many valence electrons? We just checked it. It has 5. 1, 2, 3, 4, 5. Okay, so this is the electron dot. Well, we're going to show how they bond. So beryllium wants to give away these 2 electrons. Nitrogen wants to take 2 electrons. So beryllium with its 2 valence electrons and nitrogen with its 5. Beryllium can give 1 right there to nitrogen and give its other one away to nitrogen. And look, beryllium has none. Underneath it has a full valence shell, just like helium. But the problem is nitrogen has an open spot right here, and we can't have open spaces or leftovers. So we're going to add another beryllium atom. Okay, 2 valence electrons. Well, beryllium is going to give 1 of those valence electrons to nitrogen right there, but look what happened. Beryllium's got a leftover. That's not going to work. So we add another nitrogen. 1, 2, 3, 4, 5. Beryllium has that last valence electron it's going to give to this nitrogen, but now nitrogen has 2 open spots still. We can't have that. So we'll do 1 more beryllium with 2 valence electrons. Those 2 valence electrons are going to go right there onto nitrogen. When it does, nitrogen will have 8. Each nitrogen will have 8. Each beryllium has lost 2 electrons, which means underneath it has the same valence structure as helium. So it has a full shell underneath. The formula is 3 berylliums and 2 nitrogens. So it's Be 3 and 2. That's how you do that one. Alright, so we're going to write these formulas using a crisscross method. So I'm going to go all the way across with zinc and show you how it bonds, and you can crisscross and make the formulas. It's really pretty easy. So zinc has a +2 oxidation number, right? So we write zinc +2. And chlorine, because that's where zinc and chlorine are intersecting here, chlorine has what? Has a -1 oxidation number. So I take that 2 and I put it down here as a subscript for chlorine. Then I'm going to take the 1 and put it down here as a subscript for zinc. You don't have to take these charges here. They kind of just go away. They don't really mean anything at this point. So when you crisscross these, the formula will be ZnCl2. Well, why didn't I write a 1 right there? Well, it's just like math. If I don't write the 1, then it's understood. So my formula is ZnCl2 when I do the crisscross. All right, zinc and oxygen. Zinc has a +2 oxidation number. Oxygen has a -2 oxidation number. So we're going to crisscross those two, and we'll have Zn2O2. But just like in math, if these numbers can be reduced, if these numbers can be divided by the same thing, they have to be. So both of these can be divided by 2. So our final answer here would be ZnO. 1 and 1. Okay, last one, zinc and phosphorus. Zinc has a +2 oxidation number. Phosphorus has a -3 oxidation number. Crisscross that 2 and the 3, and you get Zn3P2. Way easier than drawing all those lines, isn't it? Crisscross, pretty easy. Okay, go down here. What's the oxidation state of a magnesium cation? Okay, well, we got a clue right there. Cations are positive ions. So if it's a positive ion, that takes that one out and takes that one out. So now all I have to do is figure out which one of these it is. Well, I go back to the periodic table. Magnesium is in group 2. It's going to want to lose those 2 valence electrons. When it does, it will have a full octet of electrons in the next inside energy level. So it's going to lose 2 electrons and form a +2 cation. Like that. Okay, let's do some formula, right? Nope, naming first. Okay, so the instructions up here, name the cation first, which cation is a positive ion, and that will always be written first. Then name the anion, but change the ending to IDE. So Ca is calcium. So I just write the name calcium. Oh, I can't spell and write at the same time. Instead of saying calcium sulfur, this thing is going to be calcium sulfide. Okay, we took off the ending of sulfur and added IDE. Calcium sulfide. This one, what's the cation? Aluminum. Okay, instead of saying it's aluminum iodine, I'm going to say it's aluminum iodide. Aluminum iodide. That's how you do the naming. Name the positive ion first. Write the name of the negative ion, but change the ending to IDE. We'll definitely cut you some breaks until you get used to how much to take off and add the IDE. Just do your best. Okay, some of them are easier than others. Sulfur is hard. You would think it's sulfuride, but it's not. It's just sulfide. Okay, you'll get used to it. All right, writing formulas. So what you're going to do is you're going to write the symbols. I'll write the symbols up here. Symbol for magnesium is Mg, and the symbol for fluoride is F for fluorine. Above each of the symbols, you're supposed to write the oxidation number. So magnesium is in group 2. So it has an oxidation number of +2. Fluorine is a halogen, and fluorine has an oxidation number of -1. Crisscross them. Remember? Just crisscross them. That's all you have to do. Make it easier on yourself. So the formula for magnesium fluoride is MgF2. Okay, next one, beryllium fluoride. Beryllium is Be. It's in group 2, so it has a +2 oxidation number. Oh, yeah, wait, there we go. Fluorine, now I did fluorine again. So fluorine is still a -1. Crisscross those. BeF2. Remember not to write the 1s. It's understood if there's nothing there, it's a 1. let's try strontium bromide. Strontium is SR. It's in group 2. Bromide is just bromine with the ending changed. It's a halogen, and it has a -1 oxidation number. Crisscross them, and you get SR, BR to strontium bromide. Okay, crisscross, it makes it a lot easier than having to draw the arrows. Okay, and you'll get to a point where you'll be able to do this without even doing this part with the crisscrossing. Okay, you'll be able to look and go, okay, I know what those oxidation numbers are, and swap them. So good luck, and let us know if you have any questions.